Welcome to today's lesson on extraction of copper. Have you ever thought why we should produce copper? It's hard to imagine a world without copper. We rely on copper for power, lighting, communications, water supply, and transport. Copper makes our homes, schools, and businesses efficient, comfortable, and decorative, and it lasts for many years. ਹਰ ਸਾਲ ਦੁਨੀਆ ਵਿੱਚ ਕਾਪਰ ਦੀ ਡਿਮਾਂਡ 15 ਮਿਲੀਅਨ ਟਨਸ ਹੁੰਦੀ ਹੈ। ਕਾਪਰ ਵਿੱਚ ਰਿਮਾਰਕੇਬਲ ਕੰਬੀਨੇਸ਼ਨ ਪ੍ਰੋਪਰਟੀਜ਼ ਹਨ। ਇਹ ਇੱਕ ਬਹੁਤ ਵਧੀਆ ਇਲੈਕਟ੍ਰੀਕਲ ਅਤੇ ਥਰਮਲ ਕੰਡਕਟਰ ਹੈ। ਇਹ ਡਕਟਾਈਲ ਹੈ ਅਤੇ ਬੈਕਟੀਰੀਅਲ ਗਰੋਥ ਨੂੰ ਪ੍ਰੀਵੈਂਟ ਕਰ ਸਕਦਾ ਹੈ। ਸਾਰੇ ਰਿਸੋਰਸਿਸ ਵਾਂਗ ਕਾਪਰ ਦੀ ਸਪਲਾਈ ਵੀ ਲਿਮਿਟਿਡ ਹੈ। ਜਦੋਂ ਤੋਂ ਕਾਪਰ ਦੀ ਮਾਈਨਿੰਗ ਸ਼ੁਰੂ ਹੋਈ ਹੈ, ਉਦੋਂ ਤੋਂ ਇਸ ਦਾ ਰੀਸਾਈਕਲ ਵੀ ਹੋ ਰਿਹਾ ਹੈ। ਅੱਜ ਦੀ ਡਿਮਾਂਡ ਦੀ 40% ਪੂਰਤੀ ਰੀਸਾਈਕਲਡ ਕਾਪਰ ਨਾਲ ਹੀ ਹੁੰਦੀ ਹੈ, ਤਾਂ ਜੋ ਧਰਤੀ ਤੇ ਇਸ ਰਿਸੋਰਸ ਨੂੰ ਕੰਜ਼ਰਵ ਕੀਤਾ ਜਾ ਸਕੇ। ਕਾਪਰ ਦੀ ਰੀਸਾਈਕਲਿੰਗ ਜਿੰਨੀ ਵਾਰੀ ਚਾਹੋ ਓਨੀ ਵਾਰੀ ਸੰਭਵ ਹੈ, ਕਿਉਂਕਿ ਬਾਰ-ਬਾਰ ਗਰਮ ਕਰਨ ਤੇ ਵੀ ਇਹ ਆਪਣੀ ਪ੍ਰੋਪਰਟੀਜ਼ ਨਹੀਂ ਗੁਆਉਂਦਾ। ਫॉर एग्जाम्पल, ओल्ड कॉपर प्लंबिंग पाइप्स, टैप्स ਅਤੇ ਕਾਰ ਰੇਡੀਏਟਰਸ ਰੀਸਾਈਕਲਡ ਕਾਪਰ ਦੇ ਮੇਜਰ ਸੋਰਸ ਹਨ। ਇਹਨਾਂ ਨੂੰ ਮੈਲਟ ਕਰਕੇ ਨਵੇਂ ਪ੍ਰੋਡਕਟਸ ਬਣਾਏ ਜਾ ਸਕਦੇ ਹਨ। ਫਿਊਚਰ ਵਿੱਚ ਮੋਬਾਈਲ ਫੋਨ ਵਿੱਚ ਮੌਜੂਦ ਕੁਝ ਗ੍ਰਾਮ ਕਾਪਰ ਦੀ ਵੀ ਰੀਸਾਈਕਲਿੰਗ ਕੀਤੀ ਜਾਵੇਗੀ। Before we discuss any further, let us discuss the learning objectives for today's lesson. On completion of this topic, learners will be able to describe occurrence and important ores of copper, explain extraction of copper from sulfide ore, explain uses of copper, list and discuss alloys of copper, explain recycling of copper, draw the flowchart for extraction of copper.
Children, we all know from our previous knowledge that copper has chemical symbol Cu. Copper has many isotopes, but copper with atomic mass 64 is most abundant. It has 29 protons and 35 neutrons. An atom of Cu is represented as shown on screen. The symbol of copper is derived from its Latin name cuprum. Cu is one of the transition metals just like Fe. In transition metals, electrons from few of the outer shells participate in chemical reactions. It is placed in the periodic table after Fe, Co and Ni, as their properties are similar. I'm sure you know that Cu is non-magnetic. Let us now discuss about the occurrence and important ores of copper. Copper is an unreactive metal. It reacts only slowly with the atmosphere. The abundance of copper in the Earth's crust is only 0.0068%. This means that huge lumps of copper metal are found buried in the ground as nuggets in extremely pure form. This is called native copper. The largest nugget of native copper ever found came from Minnesota, USA, and weighed over 400 tons. In spite of low abundance, the annual production of copper reaches 9 million tons worldwide. It occurs as native copper as well as in combined state. There are more than 100 different minerals of copper found in nature. Let's have a look at the main ores of copper, their formula and their percentage purity as shown on the screen. The first one is copper glans or chalcocite, having the formula Cu2S and having the percentage purity of 79.8%. The next one is copper pyrite or chalcopyrite, having the formula CuFeS2, having percentage purity of 34.5%. The third one is malachite, having formula of CuCO3.CuOH whole twice. The fourth one is cuprite or ruby copper, having formula of Cu2O and percentage purity of 88.8%. Fifth one is azurite, having formula of 2CuCO3.CuOH whole twice, percentage composition of 55.1%. The main copper producing countries are China, Mexico, USA and Russia. In India, copper belts are located at Singhbhum in Bihar and Khetri in Rajasthan. Let us now discuss in detail about the extraction of copper from sulfide ore. Native copper, that is copper, in extremely pure form is found only near Lake Superior in America. It is mainly extracted from copper pyrites, CuFeS2. The sulfide ore is usually of very low grade and contains iron sulfide and small quantities of arsenic, antimony, selenium, tellurium, silver, gold and platinum. The various steps involved in the extraction are crushing and concentration. The ore is crushed in jaw crushers and then finely powdered. It is concentrated by froth flotation process. In this process, the finely powdered ore is mixed with water and some pine oil in presence of excess air. A blast of air is passed through the suspension. The particles are preferentially wetted by oil and rise to the surface of the tank in the form of a froth or foam, from where these are skimmed off. The siliceous and earthy impurities are preferentially wetted by water and sink to the bottom of the tank. Let us have a look at an animation to understand it better.
Copper is extracted from copper pyrites. The animation here illustrates the process of crushing. The ore is crushed in jaw crushers and concentrated by the froth flotation process. The crushed ore is mixed with pine oil and water. Air is blown into the container and froth is formed at the top from where it is removed. The impurities wetted with water sink to the bottom of the container.
Let us now learn about the second process, that is the process of roasting. The concentrated ore is roasted, that is heated strongly in the presence of excess air in a reverberatory furnace. During roasting, the following changes occur. Moisture is removed from the ore and it becomes dry. The impurities of sulfur, arsenic, antimony and phosphorus are removed as their volatile oxides. The reactions which take place are shown on the screen. Sulfur reacts with oxygen to form sulfur dioxide. Phosphorus reacts with oxygen to form phosphorus pentoxide. Arsenic and antimony too react with oxygen to form their respective oxides. Copper pyrites is converted to ferrous sulfide, FeS, cuprous sulfide, Cu2S, as shown on the screen. Copper pyrites reacts with oxygen to form cuprous sulfide, ferrous sulfide and sulfur dioxide. The ferrous sulfide so formed reacts with more oxygen to form ferrous oxide, FeO, and sulfur dioxide. The cuprous sulfide formed reacts with oxygen to form copper 1 oxide or cuprous oxide and sulfur dioxide.
ਬੱਚਿਓ, ਇਹ ਵੇਖੋ ਕਿ concentrated ore ਕਿਵੇਂ ਰੋਸਟ ਹੋ ਰਹੀ ਹੈ। ਇਸ ਨੂੰ reverberatory furnace ਅੰਦਰ ਹਵਾ ਦੀ ਐਕਸੈਸ ਵਿੱਚ ਤੇਜ਼ੀ ਨਾਲ ਗਰਮ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਇਸ ਪ੍ਰੋਸੈਸ ਦੇ ਦੌਰਾਨ impurities volatile oxides ਦੇ ਰੂਪ ਵਿੱਚ ਨਿਕਲਦੀਆਂ ਹਨ। ਰੋਸਟਿੰਗ ਦੇ ਦੌਰਾਨ ਕਾਪਰ ਪਾਇਰਾਈਟ ਆਕਸੀਡਾਈਜ਼ਡ ਹੋ ਜਾਂਦੀ ਹੈ ਅਤੇ ਸਲਫਰ ਡਾਈਆਕਸਾਈਡ ਦੇ ਰੂਪ ਵਿੱਚ ਰਿਮੂਵ ਹੋ ਜਾਂਦਾ ਹੈ। ਇਕਨੋਮਿਕ ਅਤੇ ਐਨਵਾਇਰਨਮੈਂਟਲ ਰੀਜ਼ਨਸ ਕਾਰਨ ਇਸ ਦੇ ਐਕਸਟ੍ਰੈਕਸ਼ਨ ਦੇ ਬਾਈ ਪ੍ਰੋਡਕਟਸ ਨੂੰ ਕਈ ਤਰ੍ਹਾਂ ਰੀਯੂਜ਼ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਫॉर ਐਗਜ਼ਾਮਪਲ ਸਲਫਰ ਡਾਈਆਕਸਾਈਡ ਗੈਸ ਨੂੰ ਕੈਪਚਰ ਕਰਕੇ ਸਲਫਿਊਰਿਕ ਐਸਿਡ ਵਿੱਚ ਬਦਲਿਆ ਜਾਂਦਾ ਹੈ, ਜੋ ਕਿ ਐਕਸਟ੍ਰੈਕਸ਼ਨ ਪ੍ਰੋਸੈਸ ਵਿੱਚ ਯੂਜ਼ ਹੁੰਦਾ ਹੈ। 2CuFeS2 plus O2 gives Cu2S plus 2FeS plus SO2.
Let us now have a look at the third process, which is the process of smelting. The roasted ore is mixed with some powdered coke and sand and is heated strongly in a blast furnace. The blast furnace is made up of steel and is lined inside with fire bricks. A blast of hot air is introduced at the lower part of the furnace. The following changes occur during smelting. Most of the ferrous sulfide gets oxidized to ferrous oxide, which combines with silica to form fusible slag. The equations on the screen show that two molecules of FeS reacts with 3O2 to form 2FeO and 2SO2. FeO reacts with SiO2 to form FeSiO3, which is known as ferrous silicate or slag. The slag being lighter floats and forms the upper layer. It is removed through the slag hole from time to time. During roasting or in the blast furnace, if any oxide of copper is formed, it combines with FeS and is changed back into its sulfide. 2Cu2S reacts with 3O2 to form 2Cu2O and 2SO2. Cu2O then reacts with FeS to form Cu2S and FeO. Ferrous oxide then formed again combines with silica to form more slag. FeO reacts with SiO2 to form FeSiO3, which is known as slag. As a result of smelting, two separate layers are formed at the bottom of the furnace. The upper layer consists of slag and is removed as a waste. The lower layer of molten mass contains mostly cuprous sulfide and some traces of ferrous sulfide. It is called matte and is taken out from the tapping hole at the bottom. Let us now come to the fourth process, which is called bessemerization. Copper metal is extracted from molten matte through bessemerization. This means that the molten matte from the blast furnace is transferred into a Bessemer converter, which upholds the tuyeres. The vessel is made of steel and is lined inside with lime or magnesium oxide. A hot blast of air mixed with sand is blown into the molten matte. During this process, traces of ferrous sulfide present in the matte is oxidized to FeO, which combines with silica to form slag. 2FeS reacts with 3O2 to form 2FeO and 2SO2. FeO then reacts with SiO2 to form FeSiO3. Copper sulfide is partially oxidized to cuprous oxide, which further reacts with remaining copper sulfide to form copper and sulfur dioxide, which can be shown on the screen as 2CuS reacts with 3O2 to form 2Cu2O and 2SO2. Cu2S then reacts with 2Cu2O to form 6Cu and SO2. Reaction ਦੇ ਕੰਪਲੀਟ ਹੋਣ ਤੇ ਕਨਵਰਟਰ ਟੇਢਾ ਹੋ ਜਾਂਦਾ ਹੈ ਅਤੇ ਮੋਲਟਨ ਕਾਪਰ ਨੂੰ ਸੈਂਡ ਮੋਲਸ ਵਿੱਚ ਪਾ ਲਿਆ ਜਾਂਦਾ ਹੈ। ਠੰਡਾ ਹੋਣ ਤੇ ਮੈਟਲ ਵਿੱਚੋਂ ਸਲਫਰ ਡਾਈਆਕਸਾਈਡ, ਨਾਈਟ੍ਰੋਜਨ ਅਤੇ ਆਕਸੀਜਨ ਨਿਕਲਦੀ ਹੈ। ਇਸ ਤਰ੍ਹਾਂ ਪ੍ਰਾਪਤ ਹੋਈ ਕਾਪਰ 99% ਪਿਓਰ ਹੁੰਦੀ ਹੈ ਅਤੇ ਬਲਿਸਟਰ ਕਾਪਰ ਦੇ ਨਾਮ ਤੋਂ ਜਾਣੀ ਜਾਂਦੀ ਹੈ। ਜਦੋਂ ਇਹ ਲਿਕੁਇਡ ਸੋਲਿਡਿਫਾਈ ਹੁੰਦਾ ਹੈ ਤਾਂ ਉਸ ਵਿੱਚੋਂ ਡਿਸੋਲਵਡ SO2 ਨਿਕਲਦੀ ਹੈ ਅਤੇ ਮੈਟਲ ਦੇ ਸਰਫੇਸ ਤੇ ਬਲਿਸਟਰ ਬਣ ਜਾਂਦੇ ਹਨ। ਇਸ ਲਈ ਇਸ ਨੂੰ ਬਲਿਸਟਰ ਕਾਪਰ ਦਾ ਨਾਮ ਦਿੱਤਾ ਜਾਂਦਾ ਹੈ।
Children, let us now have a look at the process of bessemerization. Molten copper sulfide along with some impurities is transferred to the Bessemer converter. Oxygen is blown into the reaction mixture. 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2 and Cu2S plus 2Cu2O gives 6Cu plus SO2. During Bessemerization, copper sulfide is oxidized to copper and is collected in containers. This copper is 99% pure and is known as blister copper. It is refined by using the electrolytic method. Impure copper is made the anode while pure copper is made the cathode. The electrolyte is made of copper sulfate.
Let us now try to understand the fifth process, that is refining. Let us try to understand how blister copper is purified. Polling. The blister copper is purified by heating it strongly in a reverberatory furnace in the presence of excess of air. The impurities are either removed as volatile oxides or converted into slag. Some of the copper also changes to cuprous oxide. This is reduced back to copper by stirring the molten metal with green poles of wood. The hydrocarbons present in these freshly cut poles reduce cuprous oxide to copper, which is about 99.5% pure. Further, purification is done by electrolytic refining. Electrolytic refining. The crude copper is further purified by electrolytic method. In this method, a thin sheet of metal is made as cathode and the block of crude metal is made as anode. Both the electrodes are placed in an acidified copper sulfate solution. When electric current is passed through the solution, impure copper from anode goes into the solution and pure copper from the solution gets deposited on the cathode. Reaction taking place at anode is copper loses 2 electrons to form copper ion with 2 positive charge. Reaction which takes place at the cathode is copper accepts 2 electrons to form copper. The impurities of zinc, nickel, iron, etc. get collected below the anode as anode mud. Alternatively, prolonged exposure of copper pyrites to air and rain leads to the formation of dilute solution of copper sulfate. Copper can be precipitated from this solution by the addition of scrap iron. It is then refined electrolytically.
Electrolytic refining. Smelting process ਤੋਂ ਪ੍ਰਾਪਤ ਹੋਈ ਕਾਪਰ ਵਿੱਚ ਕਈ ਸਾਰੀਆਂ ਇੰਪਿਉਰਿਟੀਜ਼ ਹੁੰਦੀਆਂ ਹਨ। ਇਸ ਨੂੰ ਕਾਪਰ ਸਲਫੇਟ ਦੇ ਐਸਿਡਿਫਾਈਡ ਸੋਲੂਸ਼ਨ ਨਾਲ ਭਰੇ ਚੈਂਬਰ ਵਿੱਚ ਇਲੈਕਟ੍ਰੋਲਿਸਿਸ ਰਾਹੀਂ ਹੋਰ ਰਿਫਾਈਨਡ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਕਰੂਡ ਕਾਪਰ ਪਲੇਟ ਐਨੋਡ ਦੀ ਤਰ੍ਹਾਂ ਵਰਤੀ ਜਾਂਦੀ ਹੈ, ਜਦਕਿ ਪਿਓਰ ਮੈਟਲ ਦੀ ਥਿਨ ਸ਼ੀਟਸ ਕੈਥੋਡ ਦਾ ਕੰਮ ਕਰਦੀਆਂ ਹਨ। ਜਦੋਂ ਇਲੈਕਟ੍ਰੋਲਾਈਟਿਕ ਚੈਂਬਰ ਵਿੱਚੋਂ ਕਰੰਟ ਗੁਜ਼ਰਦਾ ਹੈ ਤਾਂ ਐਨੋਡ ਵਿੱਚ ਮੌਜੂਦ ਕਾਪਰ ਸੋਲੂਸ਼ਨ ਵਿੱਚੋਂ ਕਾਪਰ 2+ ਆਇਨਸ ਦੇ ਰੂਪ ਵਿੱਚ ਡਿਸੋਲਵ ਹੋ ਜਾਂਦੇ ਹਨ ਅਤੇ ਪਿਓਰ ਮੈਟਲ ਦੇ ਰੂਪ ਵਿੱਚ ਕੈਥੋਡ ਤੇ ਇਕੱਠੇ ਹੋ ਜਾਂਦੇ ਹਨ। ਇਸ ਤਰ੍ਹਾਂ 99.99% ਪਿਓਰ ਕਾਪਰ ਪ੍ਰਾਪਤ ਹੁੰਦਾ ਹੈ। Cu gives Cu2 plus 2 electron. Cu2 plus 2 electron gives Cu.
Let us now have a look at the uses of copper. Approximately 65% of copper produced is used for electrical applications. Copper has the highest electrical conductivity of any metal, apart from silver, leading to applications in power generation and transmission, generators, transformers, motors, bus bars and cables provide and deliver electricity safely and efficiently to homes and businesses. It is also used in electrical equipment in providing circuitry, wiring and contacts for PCs, TVs and mobile phones. Copper is used for making electric wires, used in electrical industry and for water and steam pipes. Copper has a key role to play in energy efficiency. The judicious use of 1 ton of copper in the energy sector makes it possible to reduce CO2 emissions by 200 tons per year on average. In the construction industry, 25% of all the copper produced is used in buildings for plumbing, roofing and cladding. Copper provides light, durable maintenance-free structures that are naturally good-looking, long-lasting and fully recyclable. Copper's naturally antimicrobial properties can be exploited in hygienic surfaces for hospitals and healthcare facilities. In the field of transport, trains, trams, cars and lorries all need copper and transport accounts for 7% of copper usage. The high-purity copper wire harness system carries the current from the battery throughout the vehicle to equipment such as lights, central locking, onboard computers and satellite navigation systems. Since it is not attacked by water or air, it is used for making utensils, containers, kettles, evaporating pans, coins, etc. It is used in electroplating and electrotyping industry. It is used in several alloys which are tougher than metal itself. The common alloys are brass, bronze, gunmetal, coinage metal, etc. Copper is also used for alloying with gold and silver to make them hard for the purpose and of making ornaments and coins. Let us now have a look at few alloys of copper.
We will now have a look at different alloys, their percentage composition and their uses. Brass has 60% copper and 40% zinc and is used for making utensils, condenser tubes, cartridge caps. Bronze is formed of 90% copper and 10% tin. It is used in making coins, statues and control valves. Aluminium bronze is formed of 90% copper and 10% aluminium. It is used in making coins, picture frames, golden powder for paints, jewelry, bells and gongs. Bell metal is formed of 80% copper and 20% tin. It is used in forming bells and gongs. Gun metal 88% copper, 10% tin ਅਤੇ 2% ਜ਼ਿੰਕ ਤੋਂ ਬਣਦਾ ਹੈ। ਇਸ ਦਾ ਇਸਤੇਮਾਲ ਗੀਅਰਸ, ਬੈਰਿੰਗਸ, ਕਾਸਟਿੰਗਸ ਆਦਿ ਬਣਾਉਣ 'ਚ ਹੁੰਦਾ ਹੈ। ਜਰਮਨ ਸਿਲਵਰ ਵਿੱਚ 25 ਤੋਂ 50% ਕਾਪਰ, 25 ਤੋਂ 35% ਜ਼ਿੰਕ ਅਤੇ 10 ਤੋਂ 35% ਨਿਕਲ ਹੁੰਦੀ ਹੈ। ਇਸ ਦੀ ਵਰਤੋਂ ਯੂਟੈਂਸਿਲਸ ਅਤੇ ਰੈਜ਼ਿਸਟੈਂਸ ਵਾਇਰ ਬਣਾਉਣ ਵਿੱਚ ਕੀਤੀ ਜਾਂਦੀ ਹੈ। ਫਾਸਫੋਰ ਬ੍ਰੌਂਜ਼ ਵਿੱਚ 95% ਕਾਪਰ, 4.8% ਟਿਨ ਅਤੇ 0.2% ਫਾਸਫੋਰਸ ਹੁੰਦਾ ਹੈ। ਇਸ ਦੀ ਵਰਤੋਂ ਸਪ੍ਰਿੰਗਸ ਅਤੇ ਇਲੈਕਟ੍ਰੀਕਲ ਇਕਵਿਪਮੈਂਟਸ ਬਣਾਉਣ ਵਿੱਚ ਕੀਤੀ ਜਾਂਦੀ ਹੈ। ਮੋਨਲ ਮੈਟਲ ਵਿੱਚ 30% ਕਾਰਬਨ, 67% ਨਿਕਲ, 3% ਆਇਰਨ ਐਂਡ ਮੈਗਨੀਜ਼ ਹੁੰਦਾ ਹੈ। ਇਸ ਦਾ ਇਸਤੇਮਾਲ ਐਸਿਡ ਪੰਪਸ ਅਤੇ ਐਸਿਡ ਕੰਟੇਨਰਸ ਬਣਾਉਣ ਵਿੱਚ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਗੋਲਡ ਕਾਪਰ ਐਲੋਏ ਵਿੱਚ 90% ਗੋਲਡ ਅਤੇ 10% ਕਾਪਰ ਹੁੰਦਾ ਹੈ। ਅੰਤ ਵਿੱਚ ਜਿਸ ਬਾਰੇ ਅੱਜ ਅਸੀਂ ਪੜਾਂਗੇ ਉਹ ਹੈ ਕੌਂਸਟੈਂਟਨ, ਜਿਸ ਵਿੱਚ 60% ਕਾਪਰ ਅਤੇ 40% ਨਿਕਲ ਹੁੰਦਾ ਹੈ।
Let us now try to understand recycling of copper and understand why it should be recycled. Why recycle? Copper is one of many metals that can be recycled. The reasons for recycling copper are: price of copper. limited resources, energy efficiency, landfill cost, and the environment. Price. It is cheaper to recycle copper than to mine and extract new copper. Recycled copper is worth up to 90% of the cost of the original copper. Recycling helps to keep the cost of copper products down. A car contains copper wiring and a radiator made from copper and brass. The total weight of copper and copper alloys is between 15 kg and 25 kg. This can all be recycled. Limited resources. To date, only 12% to 13% of all known reserves have been mined. However, it still makes sense to conserve the remaining ore by recycling. Energy efficiency. Copper ਦੀ ਮਾਈਨਿੰਗ ਅਤੇ ਐਕਸਟ੍ਰੈਕਸ਼ਨ ਤੇ ਲੱਗੀ એનર્ਜੀ ਦਾ ਕੇਵਲ 15% ਭਾਗ ਹੀ ਕਈ ਟਨ ਕਾਪਰ ਦੀ ਰੀਸਾਈਕਲਿੰਗ ਲਈ ਕਾਫੀ ਹੈ। ਇਸ ਤਰ੍ਹਾਂ ਫੋਸਿਲ ਫਿਊਲਸ ਦੀ ਤਾਂ ਬਚਤ ਹੁੰਦੀ ਹੀ ਹੈ ਤੇ ਨਾਲ ਹੀ ਵਾਤਾਵਰਣ ਵਿੱਚ ਕਾਰਬਨ ਡਾਈਆਕਸਾਈਡ ਵੀ ਘਟ ਛੱਡੀ ਜਾਂਦੀ ਹੈ। ਲੈਂਡਫਿਲ ਕਾਸਟ। ਇੰਡਸਟਰੀ ਅਤੇ ਹਾਊਸਹੋਲਡ ਵੇਸਟ ਨੂੰ ਯੂਜੂਅਲੀ ਗਰਾਊਂਡਸ ਤੇ ਹੋਲਸ ਵਿੱਚ ਡੰਪ ਕੀਤਾ ਜਾਂਦਾ ਹੈ, ਜਿਸ ਨੂੰ ਲੈਂਡਫਿਲ ਕਹਿੰਦੇ ਹਨ। ਇਹ ਹੋਲਸ ਤੇਜ਼ੀ ਨਾਲ ਭਰ ਰਹੇ ਹਨ ਅਤੇ ਇਸ ਲਈ ਇਹਨਾਂ ਨੂੰ ਯੂਜ਼ ਕਰਨ ਦੀ ਕਾਸਟ ਦਿਨੋ ਦਿਨ ਵੱਧ ਰਹੀ ਹੈ। ਹੁਣ ਵੇਸਟ ਨੂੰ ਲੈਂਡਫਿਲ ਵਿੱਚ ਡਿਸਪੋਜ਼ ਕਰਨਾ ਇੱਕ ਐਕਸਪੈਂਸਿਵ ਆਪਸ਼ਨ ਬਣ ਗਿਆ ਹੈ। ਰੀਸਾਈਕਲਿੰਗ ਦੁਆਰਾ ਇਸ ਕਾਸਟ ਨੂੰ ਅਵੋਇਡ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ। Environment. When any metal is mined and refined, gases and dust are released. Although these are collected by metal producers, with recycling there are virtually no emissions. This helps the environment. An undersea copper cable. This can be recycled and made from recycled copper. Where does the recycled copper come from? There are two types of copper scrap. Old scrap comes from the public. It is collected from discarded, dismantled or obsolete products at the end of their lives. For example, copper pipes from old buildings, old taps from a bathroom renovation, old hot water cylinders or disused electrical cable. New scrap comes from factories which make articles from copper, brass or bronze. Their machines will produce offcuts and shavings that can be collected and returned for recycling. Copper is made with different purities depending on the application. The highest grade copper is called electrical grade. It is 99.99% pure and is used for electrical cables because it has the best electrical conductivity. Electrical grade scrap must never be mixed with any of the lower purity grades such as plumbing tube scrap. This contains too much phosphorus, which drastically reduces the electrical conductivity. The lower grades of scrap can be used to make copper alloys or chemicals. The copper sulfate you use in your school laboratory has probably been made with scrap copper. Brass scrap such as old taps must only be used for melting down and making into new brass articles. Today, we learn about occurrence and important ores of copper, extraction of copper from sulfide ore, crushing and concentration, roasting, smelting, bessemerization, refining, uses of copper, alloys of copper and recycling of copper. Let us now have a look at the flowchart which summarizes the extraction of copper.
Copper pyrites having the formula CuFeS2 is crushed to small pieces by crushing. The ore is then concentrated by froth flotation process. The ore is then roasted. 2CuFeS2 plus O2 gives Cu2S plus 2FeS plus SO2. 2FeS plus 3O2 gives 2FeO plus 2SO2. Roasted ore is converted to matte by the process of smelting by adding sand and coke. In the process of smelting, the following reactions take place. Matte plus sand gives blister copper. 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. 2Cu2O plus Cu2S gives 6Cu plus SO2. Purification is carried out with the help of two processes. First, poling, and second, electrolytic refining. The result is pure copper.
So, now we come to the end of today's topic. Here's a quick test for you to find out how much you have actually absorbed. First question that I'm asking, from where is the name of copper derived? Answer is, the symbol of copper is derived from its Latin name cuprum. Next question is, what is the composition of copper matte? Answer is, copper matte contains cuprous sulfide, that is Cu2S, and iron sulfide, that is Fes. Next question is, what types of ores are roasted? Answer is, sulfide ores are roasted. Next question is, why pine oil is used for froth flotation method? Answer is, pine oil is added in froth flotation method because it enhances the non-wettability of the mineral particles. Question is, name few ores of copper along with their formulas. Answer to this question is, few ores of copper along with their formulas are shown on the screen. Let us have a look at them. The first one is copper glans or chalcocite, having the formula Cu2S. The next one is copper pyrite or chalcopyrite, having the formula CuFeS2. The third one is malachite, having formula of CuCO3.CuOH whole twice. The fourth one is cuprite or ruby copper, having formula of Cu2O. Fifth one is azurite, having formula of 2CuCO3.CuOH whole twice. Well done, students. So, I hope that you all have enjoyed today's episode. Thank you, students, for the attention you have paid in understanding these concepts. I hope you have enjoyed the lesson as much as I have enjoyed.